Hello 108 students, Mr. McHugh here with you. Welcome to section 3.2. We are going to work on the slope of a line. Think of steepness. And this concept is crucial to our work coming up here in the next couple sections, so I really want to make sure everybody gets a good grasp of this. Now, there's some visuals here. I want you to think of hills. I want you to think of steps. If you're on page 148 of your textbook, you'll notice they show signs of a truck going up a hill, the grade of a hill, that steepness. Steps, like I mentioned, the slope of a roof or the pitch of a roof. And it boils down to this: rise over run. That's the concept of slope. We use slope as rise over run. Rise is vertical, the vertical change, divided by the horizontal change. Now you can see me using visual here. Vertical change over horizontal change. Notice the fraction bar means division. Okay, it's a ratio is another way to look at it. Slope is the vertical change over the horizontal change. Okay, now I try to use an illustration here of you are at the bottom of a set of steps. Turns around, if you got your measuring tape, if you measured vertically, each step is 7 inches high. The platform to step on is 9 inches high. And if we were going to calculate the slope, and what I try to get my students to think, what would it take for you to start with your toe right there in the corner, pick it up? You'd have to go vertically. You'd be forced to go up vertically 7 and across 9 inches to put your toe right smack in the corner. So you wanted to be extra safe. Again, up 7 over 9. Rise over run. Put your toe there. Up 7 over 9. Rise over run. Look at each of these red dots I've made. Can I draw a line through them? Yes, forms a straight line. So a slope is the main driver for causing a line to be formed. Rise over run. Okay, now one of the first objectives we work with here is, given 2 points on the ordered pair, calculate the slope, which is rise over run. Vertical change over horizontal change. The change in the x coordinates over the change in the, excuse me, I said that wrong. Change in the y coordinates. Y axis is what class? Vertical. X axis is horizontal. Change in the y coordinates over the change in the x coordinates. It boils down into using subscripts. For the ordered pair, it's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now here's a given theoretical pair of ordered pairs. First pair, here's the first ordered pair, x sub 1, y sub 1. We're going to put numbers in here. Here's the second one, x sub 2, y sub 2. Slope, the variable, is defined by, or represented by, the variable m. I'm not quite sure why mathematicians picked m, but it's been that way for hundreds of years, if not longer. And so slope is represented by the variable m always. Okay, now when you do this problem, over a couple years of teaching this, I try to come up with better techniques to help students do these problems correctly. Now, my first recommendation is to stack the ordered pairs vertically. Do not do them horizontally like the book shows. Stack them vertically. Realize you could label the first point x sub 1 comma y sub 1. You could label the second ordered pair x sub 2 y sub 2, and you've got these assigned values. Okay, now you're allowed to write this formula on your reference card. The slope of a line is represented by y sub 2 minus y1 divided by x2 minus x1. Okay, now what I like to do is, it's the change in the y coordinates, which is 3 minus, that's the word change, is subtraction, negative 1. Now notice you're going from here, you're going up on that subtraction. Over here now you are using the x coordinates, which is negative 5 minus a 2. Now there's nothing wrong with this answer. Watch the signs. A negative and a negative turns into a positive, so 3 plus 1 is 4. Negative 2 minus, excuse me, negative 5 minus negative 2 is negative 7. The answer is negative 4/7. Now I want to show an alternate way here. There's nothing wrong with the order that you list the ordered pairs. Okay, I'll leave them exactly the same way. Now what I want you to think about doing is, don't worry about the formula so much. If you want to, you could label these. I'm recommending x sub 2, y sub 2. This took me a long time to see this simple suggestion. Put the second pair up on top, the first pair on the bottom. Why? Because now you've got this lined up appropriately, where when you subtract the y coordinates, you've got -1 minus 3 all divided by, you subtract and stack. Subtract the y coordinates because it's the vertical. Now subtract the x coordinates. They're in order, and your eyes work better going vertically and going from top down. That's the idea I'm trying to get you guys to see. So now take 2 minus the -5. Okay, and if you do this real quick, you'll get -4/7, and you'll get the same answer. Okay, I just recommend that to you to help you out. Stack them and subtract. Okay, and if you're big on using the formulas and substituting in, I recommend you label the points the way I've just shown here. Nothing wrong this way, except you're working, subtracting, going up. It's better to subtract going down. Okay, now let's keep going here. Objective number 2, they want you to find the slope of a line from an equation. Okay, now this method A, I'm going to show it to you. You're hardly ever going to use it, but I'll cover it. Now, to find the slope of a line, you just realize you need to find two ordered pairs that are on a line. The two easiest ones to find are the x and y intercepts. So going back to the same example we've done before in section 3.1, 2x plus 3y equals 6. I let x equal 0 and solve for y, and let y equal 0 and solve for x, and I found the y-intercept and the x-intercept. Now go back and watch the previous videos or look in your class notes if you're a tad rusty on that. Now from here, you could find a slope by subtracting. I labeled them x1, y1, x2, y2, so you're going to subtract up, which is fine. And in my notes I've got 0 minus 2 and 3 minus 0. Now my suggestion would be to subtract the other way around and label them like I did up here, and watch how this would work. Now I'm going to subtract going downwards. So 2 minus 0 would be the change in the y coordinates, the rise with the vertical axis, divided by, now you're going from top to bottom, and you're taking 0 minus 3, and look at the answer. 2 divided by -3 is the same as -2 divided by 3. Quick note, no matter where the negative is down in the denominator or up in the numerator, it all equals a -2/3. Okay, so that's one way to use them. Nothing wrong with that if you chose to. This method B here, just going to try to show it to you real quick. This is the go-to way to find the slope, and you're going to put it into a very powerful formula that we're going to talk about in section 3.3. So the goal of this method is to solve and isolate the y variable. Okay, now you're going to see more of this on the next section here. So what would you do to isolate this y variable? You would have to subtract minus 2x on both sides of the equation. That would leave you 3y equals -2x plus 6. Now, to isolate the y, you would divide by the coefficient of 3 across both sides of the equation, all terms, as you can see here, and you're left with 3 divided by 3 is 1y. Y equals -2/3 x plus 2. Notice this is the same equation as we had before. It's the same problem. Look at that coefficient in front of the x. See that -2/3? That is the slope of the equation of a line. So your goal is to translate from standard form into y equals format. We're going to give that a name here. As I'll tell you right now, it's called the slope intercept. Look at the +2. That's where on the axis, on the y-axis, is up here. We've graphed this a couple times before, right here. And so given y equals mx plus b, b represents the y-intercept, and m represents the slope. That's the way you're going to do it starting in the next section. Okay, Mr. McHugh here. I'm going to sign off. I will see you for page 2, so keep working hard here on these two, on this section here. We're going to get yourself set up for page 2 coming up. Okay, I'll see you later. Bye.